G'day viewers, well, my little one wants my camera now. No, you can't have the camera. You can't film yet, you're too young. My Renogy Rover 68 Muppet charge controller has arrived. It was programmed to lithium iron phosphate batteries by default. I just reset the parameters to flooded batteries, the flooded lead acid. That's all nice and done. This thing will equalise the batteries now. This thing had to do it manually. This one wouldn't equalise the batteries either. So having this all properly set up is going to work really well. Okay, baby, just wait, okay? I'm making a video. Just wait. It's okay. It's got an earthing thing there. I was going to make a mount to have it up here on the post. It's bloody heavy. Like that. Oh, it's heavy. I've still done the mesh though. It's not going to get that hot, this thing. This thing's very well worth the money. I might tie this, get rid of this, and tie the other two panels into here. But I'll just leave that there as it is, because there's a reason I've done it like that, because I think the trainer panels I've got a slightly lower wattage. It's not a good idea to hook up the same, or you get the same panels, hook them up together, but if you get different wattage panels, hook them up separately. You don't get very good efficiencies, and that's not good for the panels. So there's all 250 watt panels, those four there. And the trainer ones I've got above me directly, I think they're 260 watts. Now I've only got those on another charge controller for that reason. That's the only way I could hook up like this, what I've done here. Not on the one string of 6 at once to go into the same thing. Because it's not too efficient to run the panels like that unless they're all matched, the same wattage. That's why I've done it like this. The two trainer panels are on here. But this is going to do everything. Anyway, this is going to do all the battery equalisation and maintenance. Oh, it's okay. Give you a quick look, my little. Okay, baby. Muppet charge stage. Chag stage. 48.1 volt, 28.6 volt as a solar panel. As the sun goes down, 6.6 amps. That's working nicely. I'm very happy with this. For the time being, I've made some improvements here. All my 3 solar panels are now hooked up to this controller. I've got some TPS. This is more than enough rated for the current. That'll handle the 10 amps easy. That's one panel, and the other 2 panels are on this one. I'm still waiting for the rest of my the supplies to arrive to hook this all up properly. Just Australia Post is kind of slow at the moment. I've redesigned my cables. No more battery clips going on here. Too much of a spark hazard. So that's all been done properly with Edison plug. Can't put any more lugs on there because I can't screw these bolts on. So I've got directly to the inverter, back charging through these 2 cables. It's working quite well anyway, rather than doing it here and here, which is the same thing, it's just messier. This is neater. That's there, there's some plug on there. I will, once my rest of my proper cables arrived, I'll do all this properly. I'll run an isolation switch on the wall here. I can turn the solar array off, should I need to service this during the day. I'm going to make it a bracket to come off the wall and sit it up right like that. Then I'll sit like that. There'll be a USB charging station and everything. I'm quite happy with this heatsink mod. This thing kicked out quite a lot more power than what it's designed for, and this heatsink has actually helped it quite a lot. So I'm quite happy with how this has worked out. It's working very well. I've just set it to it wasn't set to a BA3 setting on this particular model, which is programmed for flooded lead acid batteries. It was actually charging them as AGM as well. It's important to have the equalisation on these. If you're flattening them out a lot, working them hard, equalisation just basically overcharges the batteries a little bit to desulfate the batteries. Equalisation is another name for desulfating. I've got my fridge keeping my drinks cold, and I was equalising and putting power back into the panel of the batteries as the fridge is working. The sun's gone down a bit now, so it's sucking more power out. I checked this, I had this going last night. It was a 480 amp hour. got up this morning and checked it, it was down to about 420 amp hour overnight. And now it's gone back up to 450, so it's going to run. That's running this fridge there. It was on 3, but it's on 1 now. Too cold on 3. As you can see, look at that. You see there? It's not very cold here, which is a good thing. I'm losing a tiny bit of cold through here, a little bit. That seal will have to be changed. As you can see, that's a bit. How you doing? That's the thing I'm going to fix, but it does close. You've got to keep an eye on the ice and the frost though, because of this. I do have to repair this seal, so it's turning on a bit more than what it should at the moment. It's a little cold here. So some of that cold air is sinking out. That's the only thing that's letting it down is a seal. Oh, I find out how to adjust this catch. It's not quite there though. Gotta fix that. I'm losing a little bit of cold, not much. Not as much cold as I thought, but it turned the compressor on and off every 10 minutes or so. It doesn't seem too unusual. Anyway, it's costing me nothing to run this, which is good. That's half the enjoyment. Collecting old stuff, I can actually use these, and not actually have to run up my power bill. The shelving, I've got all the bits coming for this. All the bits I need are on their way. And I can get this 100% restored and clean the inside out. I can start using this fridge. Put that light bulb there and there. That looks nice in there. It works very well. Once this is all restored, I'm going to use this as a drinks fridge. And I'll shut this one off and repair that seal. But it works bloody good. It didn't drop below, it was about 12.5 this morning too, I might add. 12.5 volts it got down to overnight. I'm happy with this. I do love these types of lead acid flooded batteries. There's a very heavy duty lead acid flooded lead acid batteries. A little bit of corrosion there. I'm going to try and fix that. Yeah, it's fresh. What I might do is one day I'll shut all this off, polish up my terminals and get some Vaseline, coat all these with some Vaseline. That's the only one that's doing it. The rest are all bone dry. Yeah, that's a bit bone dry there. Oh, coat this on with Vaseline. Vaseline works just as good as a bought stuff to protect against corrosion damage. This is I've got my eyes open. So there's a little opportunity. I'm going to grab more of these batteries. I don't quite like these, particularly the 6 folders, because they've got the thickest and most heaviest duty plates of what are flooded type lead acid batteries. As I said, over the ones that you buy at the auto stores, these types are very, very heavily built. They're designed for extreme duty. It's a true deep cycle battery. There we go, we're charging now. I'll get about 30 amps on a good day, which is good. Awesome, look at that. Man, I'm happy with this. Woohoo. It's awesome. Eventually I'm going to make up another board just like this, have a BAZ on it. I'll set up some electricity meters off grid. Have my old some load wheel action going off the grid. A bigger bonus. But boy, I'm happy with this. I'm going to put these up on a table somehow, probably this high off the ground on a nice bench, set the inverter up higher. This is only temporary down here like this. I've got to make this all safe and a little one. Anyway, That'll be enough for now. Thanks for watching.